Hi, this is Mr. Manley. In this video, we're going to review some basics of functions. Function is a concept that you have worked with since algebra, and you work with it in Algebra 2 and then beyond. It's really mostly a language of mathematics, and we just want to review a few things about it. Firstly, these two equations here are functions. Y equals 2x minus 3 is a linear function. Y equals 4x squared minus x is a quadratic function that we'll graph as a parabola. And there's infinite variety of functions. And these equations are functions, and there are equations that are not functions, but they're perfectly fine equations. There's no reason that we have to have only equations that are functions. For instance, if I put this here and I've got y squared equals, well, yes, y squared equals 2x minus 3. Now that's not a function, but it certainly has significance, it has meaning, it has uses. But to be a function, there are certain conditions that have to be met. We're actually not going to get into those conditions too much. We will a little bit, but mostly we just want to accept that some equations are functions, and then when an equation is a function, a typical notation that we use is to substitute f of x for y. And we have to be very careful as we proceed forward with our work in functions using this notation, this f of x, because maybe at the outset you understand what it is and what it means, but then students will often forget, or they will often get involved in some other applications of functions where they start thinking of this f, and then they think of this as f times x, as if it's a multiplication. But it is never multiplication. It is always just a label. It is a placeholder. It is a name of a function. So in this case, what I've done is I've named this function f. And what I'm saying with the notation otherwise is that I'm going to substitute x values into this function f. Likewise, this second function, I could give it a different name. We don't have to name it f. F is the convention that we use when we're learning functions, but we can use any label that we want, both on the name of the function as well as what the input is as well. I don't have to call the input x. So here we've got two functions, f and g, and it is a linear function and a quadratic function. And then one of the first things that you learn with functions is this notation. If I say that, first of all, just reviewing how we read that is read as f of 2, and what it means is we're going to take and plug in a 2 for x, and that should make sense with the notation. So there's the x and there's the 2, so the 2 has become the x, and that means plug that in there. Pretty basic review of how functions work. And I just want to show you one thing that I highly recommend, is that to always think of this substitution for x in parentheses. Now you might not write it out, you might not need to show it, you might not need to take that step, but at least think of it that way. And sometimes I think it is really useful to actually write it out, to put parentheses wherever there are x's, and then substitute in the value that is being called for. And this helps prevent some mistakes that students often make. And then of course I can evaluate that. And we'll go down here. Oh, it's not f now, right? It's g. So I'm going to go g, do g of -1. And I'm going to do this parentheses for x, like so. And then I'm going to be able to evaluate the function using my properties of order in order to get the correct value here. So 4 -1 squared, of course, is +1. And I've got a 4 times 1 minus a negative 1 will be plus 1 equals 5. I will often in instruction take more steps than would probably be necessary, but I often also find that students would be better served to take more steps. I know they want to work through the most efficient way possible and save space and time, but very often errors that I see students make might be corrected if they would just take and write another line out, and that will help them to see what is actually going on with the calculation instead of trying to keep things straight in their head. So that's an introduction to function notation, not really talking about exactly, well, what is it that makes a function a function? Well, here's one way of getting at what makes a function, and that is the vertical line test. If I take those two types of functions, I'm not going to take these specific functions, but if I take these two types of functions, the first one, the f of x, was a linear function, and the second one was a quadratic function. I'm going to give myself a negative quadratic and go like that. So these are both functions. Now you may recall there was that one time in there that I said, well, what if I had this? And I took, it was before I did the f of x, and I had the y equals 2x, and I said, well, what if I square that? Okay, so let's pretend that I do that. I'm gonna leave this up here. And then what would I have with that y squared? I'll show you. I would have something that looks like this. A sideways parabola. So here we are. You can see on this page, the title of the page is the vertical line test. And presume that you're probably familiar with this, and this is a review. You may not even need the review, but moving forward, we'll say that the vertical line test is saying that if I draw a vertical line, infinite vertical lines are possible. There's no way that I can possibly touch the function. I cannot have 2 points of intersection with the function with a vertical line. And if that is the case, then I can tell by the graph that it is a function. And this kind of implicitly identifies a definition of a function, which is that for each input, there is one output. There is only one possible output for each input. And that's what makes a relationship a function. And here we are showing that vertically. This is a function. So if I did infinite vertical lines, there's no way that I could possibly have 2 points of intersection with a single vertical line. That is the vertical line test. And then finally, coming back here to this one that is some sort of y squared variety of a function, as I showed you on the previous page. Now I just one line there, and I see, oh, intersection, intersection. There are 2 points of intersection. This is not a function. And again, it's not a huge deal. I mean, function is an important concept in mathematics, particularly as you move forward into calculus. But in this case, it's just another type of equation, another type of relationship, and it's not a function because it doesn't pass the vertical line test. Okay, and finally, we're going to wrap things up here with looking at the graph of a function, f of x, and just seeing that we're clear on our notation and able to answer a couple of questions about the function based upon its graph. The first question is, what is f of negative 3 based upon the graph? So we saw earlier, if I had the equation of the function, I would plug in negative 3 for x. What does that mean graphically? I go to negative 3 on the graph, negative 3x. That's going to be over here. So there's negative 3x. And then I'm going to look at what's the output of the function. So from negative 3, I'm going to go on to the graph of the function and look at what's the output. In other words, what is the y value? And when I look at the y value, I see that the y value there is negative 2. And we can see what my scale is. My lattice points are all 1 unit. So f of negative 3 is negative 2. And then in this case, I am given the output. So this is like saying, remember, f of x is, I can pretty much say that f of x is always synonymous with y. Now, and if I can't say that, I can say that f of x is always synonymous with the output of a function. So the output of a function could be some other variable than y. But typically, for instructional purposes, it's y. So f of x is synonymous with y. And this is saying, on this function f of x, which is what this has been labeled here, I'm calling this function f of x. On this function f of x, when y is -4, what is x? So for this solution, this one is a little bit different, or a little bit not as convenient as this other one. So here I had f of -3. What is it? And then I can just go, oh, it equals -2. Well, here I can't really, I mean, I could kind of jump in and just plug in for x, but I'm actually going to have to take a separate line here and say, all right, when f of x equals -4, then x is equal to, so I'm going to go onto the graph at, remember, f of x is synonymous with y, so I'm going to go onto the graph at y equals -4. 1, 2, 3, 4, so that's here at -4, and I'm going to look at what is the x value. Well, I can see right there that the x value here is 0 based upon that x value, or that y value of -4, the x value is 0. Let's put that down. But then also notice in this case that there's another place where I've got a y value of 0, and that's here, and the x value there is 1, 2, 3, 4, 5, -5. So there are two possibilities here. Now for students, probably the students who are watching this video are working with me in a pre-calculus class that uses ALEKS, and in that particular case, you are asked just to answer with one value. It says, give one value where f of x equals -4, and you could enter either the 0 or the -5. So those are some, that is a basic review to the concept or to the notation of function. Certainly, if you have any questions, you want to bring them to me or bring them to your teacher and see if you want to get into it a little bit deeper. When we think about functions, we want to have a good sense of them graphically, we want to have a good sense of them algebraically, and we want to have a good sense of them numerically. And we've pretty much done that here, right? We looked at the equations algebraically, we're looking at the graph here, and then we looked numerically where we were plugging in values and getting values out. So that is an introduction to functions, and that will launch us off into really more and more topics, really to cover a full semester of pre-calculus.